Okay, man, I love these things. So let's say I give you this problem. Let's say I have these triangles that are growing, and I want to find the triangles in step 4, 10, 0, 43, and step n. Okay? So, no, here's the thing. No, as like if you want to pause it, think about it, whatever. I'm just going to go through it all and pause it and rewind and fast forward however you want. Okay? So, first of all, I want to be clear for this, for the purposes of this, this is one triangle, and this is one, two, three, four triangles, not five triangles. Okay? I just mean individual triangles. So, what you do is the best way to do it, I think, is just to see how it grows, you know? So, like if you look here, we start off with this one triangle, and then it grows. See? Well, let me help you out. So, this is that same triangle, but now we have some more. We have three more, actually. And now we have the same triangle. We have those three more, and then we got these three more. Okay? So you may think, hey, what's step four? Let's see. In step four, you'd have, make sure I got these. So you'd have this triangle. You'd have these three more. Okay? And then you would have these ones. Okay? And then you might say, well, how would that work next? Well, what you could then say is, okay, we have this triangle, and this triangle, and this triangle. So now we have these ones. Do you see how it's growing? And you can keep on doing that. So now that we're seeing how it's growing, let us start doing some fun math. So let's say you have steps and triangles. Step one, oh, that's just one triangle. Step two, there would be one, two, three, four triangles. Step three, well, it's the four plus one, two, three more. So seven. Okay. Okay. Next, it would be that plus, step four would be that plus those three more. 10. Awesome. So this isn't bad. Look, for step five, if I wanted step five, all I would have to do is just add three more, right? So that's 13. Yeah, this isn't bad. I'm good at this. Now step 10. Oh, that's that's a little bit of work. I don't want to. Do I really need to add three all those times? Is there like an easier way to do this? I don't know. Well, this is where the math thinking part comes in too. So, well, let's do it the long way and see if we can find a shorter way. We know 6 is 16, 7 is 19, 8 is 22, 9 is 25, and then 10 is 28. Okay, that's not too bad. Now I want step 43. And oh my gosh, step 43? That's a lot of work. I'm not adding up those threes. Is there an easier way to do this? Well, the answer is yes, there is. So now let's figure out what that is. Now, sometimes a way to figure out the easier way is to say, okay, so I want step 43. I don't know what that is. But to figure out what step 0 is. Like, what if step 1 wasn't the beginning? What if step 0 was the beginning? Okay, what would step 0 look like? Well, you may be like, I don't really know. So you can find out by looking at the pattern. So we know step 1 to step 2, we essentially add 3. Step 2 to step 3, we add 3. Step 3 to step 4, we add 3. So wouldn't we just do backwards? Step 4 to step 3, we minus 3. 3 to 2, we minus 3. 2 to 1, wouldn't we minus 3? And at step 1, to get step 0, wouldn't we minus 3 again? So we'd have 1 triangle minus 3 triangles. That's weird. That'd be a negative amount of triangles. Step 0 would be like negative 2 triangles. That's weird. That's not, is that useful? I don't think so. But hey, it could be. But we have that. Now we need step 43. So now you need to be looking at this for a plan. You need to be like, okay, what math? It becomes a puzzle. What math could I do to 1 to end up at 1? But that I could do that same math to 2 and end up at 4. And I do that same math to 3 and get 7. Now, this isn't the first time they've seen a problem like this. So maybe they do step 1 and maybe they multiply it by something. Maybe they add or subtract something and they get 1. Okay, well, if I do 1 times 1 plus 0, that's 1. But then I'd have to do 2 times 1 plus 0, because step 2. And that equals 2. Oh, but I want 4. Okay. This is tricky. Well, what if I say, okay, what if I just want to subtract? What if I do 1 times 2 minus 1? Well, that's 1. Okay, remember, I'm getting this 1 here because that's the step number. So for this one, it's step 2. So I would say, okay, I want 2 times 2 minus 1. That would be 3. Oh, that's not right, because what I want is 4. Okay. But if I make this any bigger, then that's going to throw that off too. So this is like trial and error. Okay. Yeah. So now let's see here. Okay. So 2 times 2 minus 1 won't work. What would, if I times it by 3? 1 times 3 is 3, minus 2 gives me 1. Okay, let's do that. So 2 for step 2, 2 times 3 is 6. Minus 2 gives you 4. Oh, we want 4. Okay, this is getting good. Let's try step 3. Step 3 is 3 times 3, which is 9, minus that 2, and that gives you 7. 7 is right. Yes, so this is my pattern. For any step, okay, I've got to times that by 3, so 43 needs to times that by 3 and minus 2. So 43 times 3 is 129, minus 2, 127. Okay, now what if I have step n? Well, watch this. Follow the n could be any number, but you can't set it as any number. It's a variable. So now you have n. We follow our pattern. We times it by 3. We minus 2. But I don't know what n is. So that's n times 3, but I don't know what n is. So I can't even multiply by 3 or minus 2. Mr. Schneider, the world is ending. Don't worry. We got this. If you don't know what n is, just leave it there. The answer is just n times 3 minus 2. That's it. Oh, okay. Wait a second. That's weird. The 0th step is minus 2. And there's a minus 2. I wonder if that's linked. I don't know. But anyway, this is how you do it.